So I'll start with the first question. So when you were talking about that you need to truncate, right, the
Mm-hmm.
NDP, you talk about you had kind of two ways of truncating it, right?
Mm-hmm.
And the problem with one of the two was that you didn't have the right in this case the right
Mm-hmm.
one. You didn't have the monotonicity that you wanted, right?
Mm. Yes.
Can you give an intuition why it plummets the speed profile at the end in the second one?
So an intuition that we might have because it works well would be that as we get close to the last state, maybe it would be that the somewhat the system knows it cannot uh, it cannot go further than this, and the previous state has quite a big. I mean, it's just how it's just looking at the equations. We would like to find rather than having a correct intuition and find the proof on it. What we actually did was just seeing this picture and seeing that okay, we can find an intuition that matches the picture, but it's quite hard to find an actual intuition that will be really convincing. So we could somewhat convince ourselves that yes, because the truncation is, as we see here, is quite sharp, going directly from 60 to 0 for lambda would mess quite a lot with with um, with the optimality equations. Maybe a more mathematical intuition in some way is that something we needed for the proof was to do some induction, but some backward induction starting from the last states. So and already starting from the last states, 60 for example, would have in this case trouble going from a rate lambda equals to 0 to rates lambda equals to 60. And when we had these decaying rates, instead we'd have that when doing the backward induction, lambda would be slowly increasing, and the induction would work properly in that case. So this is more of a mathematical intuition, but from a more real intuition on what happens, it would be that the speed policy, maybe we can just convince ourselves in some way that the speed policy just sees that lambda will at some point plummet, the lambda will at some point plummet itself, and that it doesn't need to work as fast in some way to be optimal because it will just lambda will brutally decrease at some point rather than just progressively. And something that to try to see if it changed anything or not was to maybe not work with linearly decaying lambdas, but instead some another decay, like for example linear decaying at first, and then no, at first constant, then linear decaying, something like this. But it would not be good enough. We really needed lambda to be linear decaying from the start to the end. So it's quite hard to really have a correct intuition that will explain everything. So maybe we can just settle with this one and then the mathematical intuition, and not really have a good explanation of why it's really this way.
Yeah, it seems surprising that you need linear and not just an R one, but I get how being so harsh would mess with the tail.
Mhm.
Thanks.
Thank you.
Are there any other questions from the audience?
Actually, I have a question.
Mhm.
So I see that, I mean, you have this rejection miss, you have this penalty. So I was wondering if you can extend the work to implement also some kind of admission control mechanism in the way that you rejected the request a priori while they join the system, instead of making the system busy and then discarding the request. Because this way, I mean, in this way, the system would be a bit more efficient, right? You just submit the request that will meet the deadline, and then, but I don't know if the mathematics will become too difficult or if you are figuring out this problem.
Well, I didn't look to it, but how would you, in this case, would have a penalty in the admission, right? Or something like this.
Yes.
We'd like to look at the. Okay,
Yes.
we didn't look at admission control, so and how we could add it, but it would be another time in the penalty, and I don't know how it would work in the overall balance of the penalty and already the cost of the processor. So yeah, I didn't really look into it, and I don't know how it would interfere with the rest. So, but maybe it could be a possibility. Like I don't know, don't see why it wouldn't be possible to study it. So yeah, I think it's a good thing to look also.
Okay, thank you.
Thanks.
I don't know if there are any more questions. There's time for one more quick question. If not, let's thank the speaker again. And we'll move on. Whoops, sorry. Let's move on to